All right, good morning. Happy Monday. Today is May 9. We are covering operations on algebraic fractions day 3. The nice thing about today is that there's nothing new. All we're going to do is remind ourselves how to add and subtract algebraic fractions and then multiply and divide algebraic fractions, right? So this is just a review day because this is a tough topic. So nothing new. We'll just do 2 quick examples together in the demo. And then most of today is just going to be you doing practice with the fractions. Looking ahead, on Wednesday coming up, we're solving equations that include algebraic fractions. On Friday coming up, it is our 5th and final quest. It is on lessons 27 to 30, which is just these 4 days on fractions. And then Monday, 1 week from today, is the last day of classes for the whole semester. And a week from Wednesday is our final exam. And just a reminder, on that final exam, you are going to bring in 2 reference sheets of your own creations. So hopefully you still have one or both from the first 2 tests. But if not, it's time to start making those things. This final exam is on everything, and so you really want to make sure you give yourself time to adequately review. And remember, this is one of these kind of slow and steady wins the race, not a marathon the night before. Okay? Questions on the calendar? Jeff? Why is there no homework due Friday? Yeah, I don't like having homework due on the day of a quest or a test. Yeah, quest is Friday. Yeah, so yeah, it's a good call. So Jeff is pointing out that that the homework assignment, the homework we're going to cover, the material we're covering Wednesday, instead of having the homework due Friday, it's due Monday. And it's just because I don't want to kind of hit you twice on Friday. Yeah, other questions on the calendar? All right, then here we are on the top of page 246 with our daily summary. In this lesson, we continue adding and subtracting algebraic fractions. We use the same process we used in our previous lesson, nothing new here. So let's refresh our memories. Here's the problem. We're going to be subtracting these 3 fractions. And the first step when we see addition and subtraction is to factor the denominators. We need a common denominator. And the way to find the lowest common denominator is to factor all the denominators first. That is always the first step for addition and subtraction. So let's give this a shot. Equals 3 over, okay, 2x plus 8. We're running through our same 3 questions for the 3 factoring methods that we know. Greatest common factor, what is it for this expression? 2. So let's factor out that 2. What's left? X plus 4. And we can't do anything more. That's completely factored. Now I'm going to give myself some extra space here because I suspect I'm going to be filling in some things that are missing in that denominator. So space on top and bottom, minus. In fact, I think I'm going to, no, maybe we're okay. All right, so next one, 2 over 5x minus 15. So 2 over 5x minus 15. We want to factor. Always look for the greatest common factor first. What is it here? 5. Fantastic. So let's pull out the 5. And we're left with x minus 3. And then we'll leave a little bit of space there. And then the last fraction is a minus 2 over, okay, x squared plus x minus 12. Greatest common factor, what is it? It's 1. That's not very helpful. So our next kind of factoring is which one? Difference of 2 squares. Is that a difference of 2 squares? Nope. It's 3 terms, so it's just dead in the water. And then finally, the last kind of factoring is the box. And does this look like a candidate for a box factoring? It does. It looks like a trinomial with an x squared and an x and a constant. Again, we're not going to spend our time in class here. We're just going to put the answer and you can verify it later. So anybody see it? X plus 4 and x minus 3. We have some expert box makers in this class. It's fine to take your time as you make the box. Okay, so now we're looking at our 3 factored denominators, and the goal is to make them all the same. So let's just look at the first 2 denominators, and we're going to try to fill in what's missing. And at the moment, these 2 denominators have nothing in common. So what's missing in the first one that the second one has? Everything, right? 5 and an x minus 3. So I'll put down here times 5 times x minus 3. Just doing what I did in isolation is illegal, so how do I make this legal? Do the same thing on the top, right? Times 5 times x minus 3. That's legal because I just multiplied by 1, a fancy form of 1. Okay, what is the second denominator missing that the first one has? So a 2 and an x plus 4. Currently illegal. Multiply the top by the same thing at exactly that moment, and now it's legal. What do we notice about the first two denominators now? They're the same. You built them to be the same. And now we'll look at this last denominator and see if it is missing anything from the second denominator. Well, let's see. It has an x plus 4. Oh, great. There was already an x plus 4 there, so it doesn't need another one. X minus 3 was already there, so it doesn't need one of those. So what is the only thing that this last one is missing? Is the 5 and the 2, right? It doesn't need the things in the parentheses because it has them already. So I knew I was going to run out of room here, and I didn't do anything about it at the start. So with apologies, we're going to squeeze this up here. 5 times 2, 5 times 2, top and bottom. In theory, you might need to take a look at the second denominator and give it stuff that the third denominator had. Like if the third denominator had more stuff that the second denominator needed, you would need to fill that in at this moment. But you can see all three denominators are exactly the same right now. So we're good. Built our lowest common denominator. Okay, so that's a big part of the puzzle here. Let's keep going. Equals. Big fraction line. All I'm going to do is smush together the three fractions into one. So downstairs, 2x plus 4, 5x minus 3. Just one copy of the lowest common denominator. Doesn't matter what order you put it in. I chose the first denominator's order. And then upstairs, we're just copying, right? So it was a 3 times 5 times x minus 3. Now we are going to smush all that together, but I don't think we should do it in the same step that we smush the fractions together. So let's just do one thing at a time. Mostly we are copying. Next symbol is minus. So we go 2 times x plus 4. It's really tempting to, to just start multiplying. And as long as you do it carefully, you'll be just fine. But I'm a fan of one thing at a time. And then minus 5 times 2 times 2. Okay, so what we've written is correct, but I'm going to add some parentheses here, just as a matter of form. I think I mentioned at one point in a previous class that I'm a big fan of just adding parentheses around every fraction that you start with, like when you go from different fractions to the same fraction. So I'm just going to throw these here, although they aren't necessary. In this particular problem, in some problems, they are necessary. So just as a matter of habit, I always put parentheses when I go from different fractions to a single fraction. Okay, and now it's time to start smushing these things together. So lots of distributing here. Okay, so let's give this a shot. 3 times 5 is 15. We're going to distribute the 15. Just got through saying I don't do 2 steps in one, but we're doing 2 steps in one right here. So 15 is getting distributed. So 15x minus 45. Minus, okay, 2 times 2 is 4. That 4 is going to distribute and give me a 4x plus 16. Are you okay with that? 4 distributing. And then finally, minus 5 times 2 times 2 is 20. Copy the denominator. Oh, at some point, maybe right at this point, like we never multiply out on the bottom, but there are two things that should get multiplied together, and those are the two numbers sitting in the front, sitting outside the parentheses. So the 2 and the 5 smush together and we just make a 10. I'll never distribute through parentheses. but pushing the 2 and the 5 together makes things cleaner, not messier, right? It's not distributing. It's just smushing together two things that belong together. Okay, if we continue from this part in the problem, we will get the answer wrong. What did we do wrong? What did I do wrong? Yeah, that positive 16 there. It's actually supposed to be a minus 16, which is a little bit funny because look, that's a 4 times a positive 4 is a positive 16, which is exactly what I wrote down. So how about we go back and put in the things that I just carelessly omitted here, which was what? What did I just drop as we went from, I dropped the parentheses. This is where it's important. That 15x minus 45 was the first parentheses. That one's not the one that's crucial. It's that one right there. That 4x plus 16 was in a single bag, and that bag was supposed to get subtracted. And when I dropped the parentheses, I didn't end up subtracting everything in the bag. The 20 doesn't need it, but we'll just put it. So this is why I'm a fan of just putting parentheses every time. Okay, and now we're ready to get rid of the parentheses legitimately. So the first parentheses don't do anything, right? 15x minus 45. The second parentheses, this is where I made my mistake. So it should be minus 4x minus 16. Last parentheses don't really do anything. Minus 20. Copy my denominator. Now we're going to combine like terms. So how many x's do we have? Let's see, 11x, that's good. Minus 45, minus 16, minus 20. Let's see, that's a 61. I get 81. Minus 81. Of the numerator and the denominator, which one has stuff that's ready to be canceled right now if it could find a partner? The denominator, because it's all multiplication, right? The denominator is multiplication. So those three things in the denominator are ready to cancel if they could find partners upstairs. The numerator has nothing in it that can cancel because of what? Because what? Addition and subtraction, right? The numerator has subtraction in it. So this problem is done, but in theory, in other cases, it might not be done if you can factor the top. Like I'm going to make something up and then erase it. But suppose that factoring, like I could factor an 11 out, which I can't. But suppose that I could, and I got x minus 3 in the parentheses. So don't copy this because I'm just making it up. But suppose that you could factor it out. Then what could you do to simplify? You could cancel the x minus 3's, right? So it's our obligation to just see if we can factor the top because maybe, just maybe, we'll be able to cancel. So let's look at the top. What's the greatest common factor? It's 1, so we can't do anything there. Is it a difference of 2 squares? No. Is it a 2 by 2 box? No. So we did our due diligence and we didn't come up with anything. But I just want to point out that you got to look for that. Questions on that one? Okay, so that's our review of addition and subtraction. Let's take a look down here at number 2, which is not an addition subtraction, but rather is a multiplication division problem. And we're putting it here just to remind ourselves of the difference because we spent one day on multiplying and dividing and another day on adding and subtracting. And now we want to make sure we don't confuse the ideas from those two processes. So first thing to do here is maybe change this division. All right, so I'm going to copy the first two guys. Multiplication I think I can handle, but the division we got to make a change. So this is me copying the first two fractions. And then how do we change that division into something more manageable? multiplication and then flip, right? So times and then flip the last guy. Change which? What sign? No, the flip is just keep everything written as is, but swap numerator and denominator. Okay. So next thing we're looking for here is factoring. So we're going to factor wherever we can. So let's take a look at the 4x plus 12 on the top left. First thing we look for is always greatest common factor. What is it? 4. So factor out of 4, and we're left with x plus 3 is good. And then downstairs, again, first things first, and that's the greatest common factor. What is it? 9, and also x to the third. And what's left? X minus 5. That's good. And then times. Next one, top middle, 3x to the 7. It's already factored. Copy it. On the bottom middle, x plus 7. Nothing to do there. So we copy that. Times. Okay, top right. Greatest common factor first. What is it? 1, not helpful. Is it a difference of 2 squares? Nope. Is it a candidate for a 2 by 2 box? Indeed it is. So again, omitting the details. What is this guy? X plus 7 and x minus 5. That's good. Take your time as you build your 2 by 2 box factors. Okay, and then the bottom right. Again, always starting from the greatest common factor. What is it here? 14. And then we go x plus 3. Good. Okay, so first I want to highlight that we've already done something different than we do for adding and subtracting fractions. For adding and subtracting fractions, what do we factor? The denominators only. And factoring the top is just spinning your wheels. But for some reason, for multiplying and dividing, you want to factor everything because now you can cancel stuff. What can we cancel? So x minus 5 on the top and on the bottom. That's why we factor the tops, right? Is because we're looking for things to cancel. We're not factoring for the purposes of making a common denominator. And in fact, we're not looking for a common denominator at all. Once we cross things off, we're basically just going to write what's left, and that's our answer. And a lot of students get just in this headspace where it's like every fraction problem involves a common denominator. And for division and multiplication, they don't. And if you try building a common denominator for a division or multiplication, you're going to lose a lot of points because that's a serious conceptual issue. Let's keep canceling here. What else? X plus 3's. Those go away. Anything else? X plus 7. All right, good. There's not much left here. Anything else? What else cancels? Yeah, I'm going to say 3 and I say 9, right? They just reduce like ordinary numbers. So 3 becomes 1, 9 becomes 3. Great. Any other ordinary numbers that will cancel? Yeah, we're going to do the x's too. Let's finish the numbers first. 4 and 14, you bet. 4 becomes 2, 14 becomes 7. Great. Okay, and then one final thing. Jesse, what were you saying? We've got x to the 7 on top and x to the third on the bottom. So how many x's are left up here? 4, right? Because if you just imagine writing all those x's out, I mean, forget our shortcut subtraction property. If you don't remember it, don't worry about it. Just imagine 7 x's on top, multiply it all together, and then 3 on the bottom. And you're going to cross off all 3, and you'll have 4 left on top. What's left on the bottom? Nothing. So put a 1 there if you want. Yeah. Okay. So there's so much canceling. It's actually easy to not be able to see what's left if you aren't careful about your writing. So I have the benefit of having lots of colors. Let's see. So I see the red 2, the red 1, and a blue X to the 4th. So 2X to the 4. Over. Downstairs I see a 3, a 1, and a 7. All multiplied, 21. Questions on that one? Okay, so just to refresh our memory, the difference between the add, subtract, and the multiply, divide. When we're doing the multiply and divide, we factor everything, not just denominators, but everything. And you cross off all the common factors, and you just write down what's left. No common denominators at all. And then there was that little thing about division flipping when it becomes multiplication. For adding and subtracting, what do we factor? Only the denominators, don't factor the numerators. And then once your denominators are factored, then you need to build. But the least common denominator. And you're only able to see that because you factored those denominators. And so you put in all the missing stuff on the bottom, immediately you put that same stuff on the top, because otherwise we're breaking the rules. And then you smush together all the numerators and combine like terms like we did above. Okay. A big part of the test, the last quest that you're going to take is essentially these two problems, different variations on those two problems. Okay, so I think that is all. Activity is on the next page. Let's see how far we can get.